Friends, welcome to the new tutorial for one of the famous Leetcode problem, which is course schedule. Today we'll see how we can solve a course schedule and some of the other problems which are related to course schedule. Let us get started. So one of the principle which is used to solve course schedule is topological sort. So what exactly is topological sort? We'll see it in the form in the coming up video. So what exactly is the course schedule problem? What course schedule problem says is is, is to check whether we can complete a course schedule which is given. What does it mean? It means that in order to complete course any course X, you need to complete course Y, and you need to check whether you can complete both the course X and Y. For example, um, in order to complete in order to complete differential equation, you need to first learn integration and differentiation as well. In order to first learn integration and differentiation, you need to learn math first. So the order is math and then integration and then differentiation together and then differential equations. So this is the correct order in which you would complete the the course for differential equation. If for example, if there is no integration in the course schedule, then you will not be able to learn the differential equation. So that is basically the concept of it. Now, the in this specific order, you see integration has a dependency on basic math, and differential also has a dependency on basic math, and differential equation has dependency on both integration and differentiation. Um, so this is a successful way of completing the course. But for example, let us assume a problem wherein you have to figure out who came first, whether a chicken or an egg. Now egg is coming from a chicken, and chicken itself is coming from an egg, so there is a cyclic dependency between chicken and egg. So in this way we cannot complete the chicken and egg course, or we cannot figure out who came first, or we cannot create a topological sort order for it. So that is basically a false case that I just narrated. Now let's go and read the question. Topological sort course schedule number 207 lead code. There are total of num courses, which is an array courses you have to take, labeled from 0 to num courses minus 1. You are given an array of prerequisites where prerequisite of I is equal to AI BI, ordered pair of AI and BI, indicating that you must take course BI first if you want to take course AI. So over here your BI becomes integration and AI becomes your uh, so AI becomes your basic math. For example, the pair 0 1 indicates that you need to take course 0. In order to take course 0, you have to take course 1 first. If you can do it, you return true, otherwise you return false. Let's take an example. In this example 1, num course, the number of courses are 2, which is 0 and 1. And yes, you can complete it because your 0 is dependent on 1. So there is only one way of doing this course. To take the course 1, you should have finished course 0 first. But in the second question, which is 1 0 and 0 1, now 0 is dependent on 1 plus 1 is also dependent on 0. So this is a classic chicken and egg problem, and it is impossible to complete the course because you cannot start a course without having finishing its dependency. So this is the basic concept of topological sort. The way topological sort works is, um, let me take you to an example of topological sort in here. So the way topological sort works is, in order to go to school, you need to wear a shirt and a hoodie. Um, you need to get dressed. Basically, how you do it, you wear shirt, hoodie, and then you you wear your underpants, pants, and belts. You wear socks, shoes. The important thing over here is you cannot wear shoes before you wearing socks. You cannot wear a hoodie before you're wearing shirt. You cannot wear your pants before you wear your underwears unless you are Superman. So it just creates an sort order. So let's see how many sort order it can create. You can wear shirt, hoodie, shoes, socks, underpants, pants, belts, shoes, etc. Like these are a couple of orders. So I hope now you understood what a topological sort is. Now, in order to do a topological sort, there are three things the way we solve it technically. So there are three things to it. First is to create the graph from the uh, given input. Like over here, we have prerequisites and number of courses. That is your input. Um, Once you have created the graph, you need to check in degree. What is in degree? In degree in any graph is number of connected edges that it has. So for example, the in degree of hoodie is 1, in degree of pants is 1, in degree of school is 2 because it is dependent on 2. So that is an in degree. So what we will do is we will take all the elements whose in degree is 0, put them in a queue, and then process the queue. It is pretty simple problem to solve. So there are three parts to it. Create the graph, initialize the graph, create the graph, process the 0 in degree, and then process the queue. So let me walk through the code for you. In order to represent the graph, which is your adjacency list, we are using adjacency list. We are going to use a hash map with an integer and a list. So this will create your adjacency list. You want to keep track of visited, because if you are visiting any element twice, which means that there is a cycle. You have to create a queue because we are using queue to solve this problem, and you have to keep track of in degree, so that whenever an element reaches in degree of 0, you can put it into the queue. So over here we are initializing our graph with empty arrays because the course numbers are from 1, so we are initializing them. And then over here, if you see the prerequisites, what we do is we say this 1 is in order to take course 0, you have to take course 1. So 0 has a dependency of 1. That's what we are putting in our adjacency list. And then adding the in degree of 0, because there is an edge coming in from 1 to 0. Now this is just the initialization part of the graph. After we have initialized, we will check for all the integers which are 0 and put them into the queue. Once we have put them into the queue, it is the easiest part. Now we have to process the queue. How do we process the queue? You do put it in a while loop and check whether queue is empty until you process the queue until it's empty. If the queue is empty, and then you poll the first element. The moment you poll the first element, you want to get its neighbor and you want to say number of processed elements. We keep a count of number of elements that are processed. I'll explain you why it is. And then we say visited is equal to true for the current element, because yes, we have already visited it. Now we get all its neighbors like here, and then check if any of the neighbor is visited. If any of the neighbor is visited, what does it mean? That there is a cycle. We have already gone to that element and we are coming again. So there is a back edge and there is a cycle, which means that if there is a cycle, it will not be able to process, or there cannot be any topological sort. If there is no cycle, then we reduce the in degree of that element of the neighbors and then check if the neighbor has in degree 0. If the neighbor has in degree 0, then we put them into the queue, and this goes on. We process all the elements. If all the elements are processed and if all the processed elements is equal to number of courses, then we can say that it is true, otherwise it's false. So that is basic course schedule. Now, so there are just three parts to it. Create the graph over here, very simple. Check for in degree and put them into the queue. Process the queue. When you are processing the queue, you just have to keep track of two things. When you process an element, you mark it as processed. Second, get all the neighbors of it and reduce its in degree because you are already processed them, and then check if their in degree is already reached 0, you put them into the queue back. This is very simple problem. This solves really the course schedule, but it just not solve course schedule. It also solves course schedule 2, which is a very simple similar problem. And in course schedule 2, it is exactly the same algorithm. What the output, what they want is the order of the course. So how would you get the order of a course? There is nothing over here. We are checking for number of elements processed. If you create a new array and put the number of processed in here, like if you start adding those elements here, then you can create a array list of the order in which the elements are processed. Let me give you an example. Here in the same thing, like we are creating an array of the order in which my queues are being processed in the queue, the order in which my elements are being processed in the queue, and that becomes your course schedule 2 problem solved. And similar to this, you can do all this. Like course schedule 3 is also very similar. You can you can check whether a graph is a tree. The graph is a tree. There are two conditions. It should be connected, that is which means that it should only have one component, and second is there should not be any back edge. So that is a valid tree. So it's very simple. These are very simple problems, and there are some of the problems which are similar here, like alien dictionary is such a simple problem. If you look at alien dictionary, it is one of the difficult problem, but in this also we follow exactly the same structure. If I think I haven't solved it, but yeah. Please let me know. This is my first interview. If you have any questions, please let me know. Post a comment, like, share, and subscribe. Thanks a lot.